Ever wondered how cities could think like a supercomputer? What if machines could actually understand the chaos of streets, buildings, and movement that makes up our urban world? Today, we're exploring a revolutionary AI model called UrbanLLaVA, a system that's redefining how we interact with cities. Let's start with a big picture. Cities are wild, right? They're packed with data, photos, maps, GPS trails, even text from street signs. But here's the problem. Most AI systems treat these pieces separately. They're like a chef who only knows how to cook pasta or salad, not how to blend them into a gourmet meal. That's where UrbanLLaVA steps in. This model is a multimodal magician. It handles 4 types of urban data at once. 1. Satellite images, the big picture view. 2. Street view photos, what you'd see walking down a road. 3. Geospatial data, like maps with addresses. 4. Trajectory data, GPS paths showing how people move. But here's the twist. UrbanLLaVA doesn't just process these inputs. It reasons with them. Think of it like a detective connecting clues. For example, if you ask, where's the nearest coffee shop? It might cross-reference a street view image with GPS data and text descriptions to give you the best answer. So how does it work? The researchers built 3 key parts. 1. UData, a massive dataset combining real-world urban info. They gathered data from Google Maps, OpenStreetMap, and more, creating a city encyclopedia for the AI. 2. UTrain, a clever training process that teaches the model to separate spatial reasoning, like reading a map, from domain knowledge, like knowing what a bakery looks like. This keeps the AI flexible for tasks from navigation to urban planning. 3. UBench, a new set of tests to measure how well AI models tackle real urban challenges, like predicting traffic patterns or identifying landmarks. The results? UrbanLLaVA outperforms other AI models in both simple tasks, like locating a building, and complex ones, like analyzing how traffic flows through a city. It's like giving a robot a 360-degree view of a city and letting it make smart decisions. But how did they make it so good? Let's break it down. The researchers tested it against other models that only used one type of data, like ones that only analyze images or only process text. And guess what? UrbanLLaVA smashed the competition. In cities like Beijing, London, and New York, it outperformed existing systems in tasks like address recognition and identifying land use patterns. In some cases, it was nearly twice as accurate as the next best model. The secret sauce? How they trained it. They experimented with different approaches, like adjusting the learning rate. Think of it as the model's speed limit for learning. They found that a slower, more careful approach, a learning rate of 1e5, helped it handle both text and images more smoothly. They also discovered that training with both data types together, instead of separately, led to better results. It's like teaching a kid to read a map and follow verbal directions at the same time, rather than one after the other. Here's another twist. Bigger models didn't always win. While larger models like the 8B and 13B parameter versions showed huge gains in some tasks, up to 122% improvement in traffic prediction, smaller models sometimes held their own. This suggests that how you train the AI matters just as much as its size. So what does this mean for the real world? Think smarter navigation apps, urban planners using AI to design better cities, or even robots that can explore unfamiliar environments. UrbanLLaVA's ability to reason about space and combine different types of information could revolutionize how we interact with our cities. Next time you're using a map app or asking a voice assistant for directions, remember, behind the scenes, AI like UrbanLLaVA is working hard to make sense of the world, one street, one image, one question at a time. Stay tuned as we explore how this tech could shape smart cities, autonomous systems, and more.